Okay, so I'm gonna go over the ppm again. Yesterday, my bad. I totally like muffed that stuff. Um, I guess looking at everything and all the numbers, I really got myself kind of confused. So I'm gonna go over just the ppm value, how you can check that you have the right structure, and how all of these ppms make sense within this molecule. Let me finish writing these. So D had a 2.9, and then E had a 1.8. Okay, that's a 9. Okay, so first let's start with the simpler ones that I think, and always remember these are estimates. ppms occur over a range, chemical shifts happen over a range. So let's start with this one. We determined F is a methyl group. It has a 0.9 reference value ppm. This one already, love it. It checks out. This also means it cannot be alpha or beta if it is a methyl group to any other functional group. If it was alpha or beta to this carbonyl, it would have a higher ppm. So we know this is off by itself, not within an alpha or beta position to a functional group. So also, if we look at this ring, so for the reference value for a ring is roughly 6.5 to 8. So these 7.5s make perfect sense for this ring. That's just the overall signal that this gave off. This is the reference that we're going to be working with, is 7.5 ppm for the ring, just in general. So, and it also makes sense. It is not, none of these B or C are alpha or beta to another major functional group, so nothing gets added to it. There's no additional ppm. So let's look at A. So A has 8. So where those come from, it's 7.5 ppm from the ring, like we established for B and C. The fact that it has an additional 0.5 that we're unsure where it came from, this tells us, based on everything that we're working with, it has to be beta to this carbonyl here. Because carbonyl, remember, has a 1 ppm value, reference value. So it needs to be beta. Because if the ring was directly connected to this carbonyl group, it would have added an entire 1. But because it's beta to the position, I'm sorry, not half. It's going to add, I believe, 20%, so 0.2, which will give us a value of 7.7 ppm. And again, these are all estimates. They're going to be close. It's not always going to be like exactly perfect. This plus this equals the exact number you're given. It just has to be super close. And that's really the only thing that you can use to rationalize what's going on, especially because A is already part of this ring. And the only other functional group that would add to it would be that carbonyl. So you know that beta to this ring, you need the carbonyl. Let's look at, which one do I want to look at now? Let's look at D. So for D, it's a methine group. Methine group has 1.2 ppm for a reference value that we were given in class. That's what we're going to work with. That's just what comes from this. So then we notice, okay, well, D is also alpha to a carbonyl group. So if it's alpha to the carbonyl group, you're going to add the full value of that carbonyl group, of that functional group, whatever it's alpha to. It is directly connected. So we're going to add 1 ppm. That gives us roughly 2.2 ppm. Well, we're still missing 7 ppm. Again, these are estimates. If you'll notice, this D right here is 2 groups away from the benzene ring, so it is beta to the benzene ring. So, and then this is something that Dr. Owen told me. The chemical shift of a beta benzene is approximately 0.5 ppm, which gives us a value of 2.7 ppm. I'm going to reiterate this one more time. These are not exact values. It's not perfectly pinpoint precise, but we had a value of 2.9 and we were able to rationalize a 2.7. So it feels like what we decided for D is it's going to be in the right place. It is beta to the benzene ring and it is alpha to the carbonyl. So this one feels good. Let's do E next. I think E is the last one we have to do. So for E, it's another methine. We start with 1.2 ppm. Now we are beta to this carbonyl group. So we're beta to the carbonyl group. We're going to add, let me see. We're going to add 0.2 ppm, roughly 20% of the 1 ppm associated with a carbonyl. So we're going to get a value of 1.4, which is what's lower than what is indicated here. But again, out of all the values we were able to obtain, this one I think we ended up getting 2.7. Obviously, this one and this one are not exchangeable, like interchangeable. They're different enough values that you can differentiate exactly which signal came from which position. I hope this made more sense. I feel really bad for messing up yesterday, but I was like knee deep in this problem and I just got myself like 50 shades of fucked up, honestly. But yeah, I hope that makes more sense. Thanks, bye.